Supposedly doing a demo for CS1 Fall 2025 for the graphics library. And the graphics library reference has a tiny little main program in the middle of the front page. And I went to the liberty to go ahead and type that in first, thank goodness, so I get to save a little bit of time. We've got to do the same stuff here. Search for idle, IDLE. And there it is. This is my own personal laptop, by the way. It would not allow me to screen record on the school desktop. Complain. File is open. The first option, does that say open? I have got to lean on your assistance here. Does that say open or new? I literally cannot see it. Oh. If I could move to the middle of the room, I could see it. Now I'm on file?
Yes. Yeah.
Thank you. Let's get a little help. Now, status CS 1124. Workshop. Project 3. No, that's not it. We're not doing Project 3 yet. It's examples. That's what I'm looking for. Examples. You see example, I think we're up to example 7. This. Graphics demo. Mercifully finally open. There it is. And that is nowhere near big enough for me to see. And since I can, I will. I want to, let's say show line numbers. And options, configure idle. I'm going to go a whopping 16, or at least, what is that? There, I think I can see it. Okay, there we are. And I'm going to file, before I get going, I'm going to separate this out. File and save as. Is that this one? No. This one? Save as. 2 up from where I am. And a new folder. Demo. Save. Run. Crash. No module named graphics. Graphics is not part of the system library where reside print and eval and input and all that stuff. It's in its own little graphics file. You can write your own library if you want to, but any homemade library like that of homemade objects, you have to put it in the same folder. And since I just now made this folder named demo, of course it's not going to be in the same folder. So that wasn't going to work. But I can put it there. I can go down here and browse to where I was, CS 1124. I think I even had it in examples. Play I Spy. Do you see graphics.py in there anywhere?
Wow.
This is what this is? Thank you. I want to copy it. Copy. There it is. Copy to my new folder demo. This was not supposed to be part of the demo. Paste. But now, when you see the red paragraph of death that says that it doesn't know what the graphics library is, that's your problem. You don't have graphics.py in the same folder. Oh no, I don't have graphics.py at all. After class, I will email you graphics.py and also graphics PDF, which is this. This is a printout of the graphics.pdf file. So you'll have the instruction guide how to use it, and you also have the library, and there should be idle open down here across the bottom somewhere. I think this is it. Let's try it again. Run module. And it worked, except it didn't do very much. Look at this. Tiny little thing with a tiny little circle. There's almost nothing there at all. but I got to click inside the window to make it go away. And then I'll get rid of this because this is just in the way, and look at the editor. What it did was it made a tiny little graphics window, which is the very first object type that's described. That's kind of like your whiteboard, where you dump your graphics objects, like our tiny little circle. It goes on a tiny little GraphWin whiteboard. The circle, well, there's gunk about the circle and all the other stuff. Let's just tackle this one line at a time. That GraphWin, I'll strongly suggest, is too small to be practical. We need a larger graphic window. So let's look at our graphics reference and see if we can figure out how to do that. The very first method on each object type is how you make an object of that type. So the very first one on GraphWin tells you how to make a GraphWin to begin with. It wants three things. It wants a title, and it wants a width and a height. And if you look at the last line of that description, there's an example. GraphWin, investment, growth, and then they've got a couple of numbers. Hi, you know me. You know I don't like couple of numbers. I am not happy with this, the way this is. The 100, 100, those are not at all self-explanatory. What do you suppose Dr. Ingham prefers instead of 100, 100? You can talk while I try to type. Talk fast, because I'm going to type it in real fast. Symbolic constants, if I can spell it. This is going to be even worse, because I can't see what I'm typing. I'm going to assume that says symbolic constants, and set one for width, all yelled and everything. But 100, that is not big enough. I'll try 500. Man, that ought to be big enough. And height, Height equals. And we probably wanted a rectangle, a nice pleasing rectangular shape rather than a square. So I'll make that 350. Now, where can I start using my symbolic constants already? In the creation of the graphics window. You're exactly right. My neck is going to be sore this evening. So instead of 100, 100, not at all self-explanatory, ridiculously cryptic. What this wants is a width and a height, so we'll give them our symbolic constants, width and height. And who knows if this will work or not? I certainly don't. I'm trying to reach for the run menu. Does that say run module? F5 is the well, my hotkeys on here don't work well. Yeah, save it. Okay, now we're in business. That is a bigger graphics window. It's finally big enough now that we can see the title. The title here is My Circle. That was specified in graphics window. Except that's not satisfying. That tiny little circle, it was in the middle of our little postage stamp whiteboard, but now 'tisn't. And I am recording this, by the way, so you don't have to write down everything I say unless you just want to. I am going to put this video on YouTube. Ideally, cross my fingers, think positive thoughts. We'll see if that works out. But here's the plan. You can help me. I want to move this little circle so it's right smack dab in the middle of my graphics window whiteboard. Does everybody understand the plan? Man. And click and make that go away. And click and make this go away. The next line, here's this is making the window, and we saw the title, My Circle. And it made a circle. It made a circle with a capital C. Look, GraphWin is with a capital G. Circle is with a capital C. Point is with a capital P. Rapidly, we see a pattern developing. That is a different naming convention. All capitals is symbolic constants. Camel-cased starting with a lowercase letter are variables. What do you suppose? Camel-cased but starting with a capital letter. What do you suppose those are? What do those things have in common? Well, for us, they're all graphics objects. But in general, when you invent a new data type, an object type is a new data type that you are inventing for Python. The nice people at the Python factory invented these for us for our graphics library. But circle is a data type with a capital C. GraphWin is a data type with a capital G. So it's still conventions that work for you so that you can tell what's going on in the code. So now that we know that circle, this circle right here, that is a data type, and so is point. I've gone as long as I can. I can go no further. I don't like the way they do that at all. I want point to be a separate object. P equals point. All this is doing is moving it. Point, fitty, fitty. That makes a point object that lives at, I think, is that 50-50? No, it's 30-30. I don't care. It lives at those two coordinates on the screen, the x coordinate and the y coordinate. And then, now that I have that point object, I don't do this. I call this constructing on the fly. This is called constructing an object, and I don't like to construct a point object on the fly. Now I've got an actual point object variable I can put in there. Let me see if I broke anything before I pontificate any further. Run, run, run. Okay. Please no red paragraph. Please no red paragraph. And there we go. We got the circle, and it's at 30-30 rather than 50-50, so it got worse rather than closer to the middle. But here's my point. See what I did there? I separated the point object from the circle object because I like the baby steps, incremental development. Let's make the point object first, and then we'll draw a circle around it. The point object, if you look that up in your graphics reference, it wants an x coordinate and a y coordinate. I'm going to stop you right there. If we want this circle to be right smack in the middle, and the point object ends up being the center of the circle that we're creating here, then what do the coordinates need to be? Can anybody do the math in their head? Yes.
It's 251.
Okay. That was easy. Thank you, sir. And let's try it. Run module. Okay. Ta-da! Perfect. Thank you very much. Well, maybe not perfect. I want it even bigger. I mean, I'm not going to go all out like the walls of this room, but I want that to be even wider. Instead of 500, I'm going to make it 650. And instead of 350, I'm going to go with 425. See if I like that better. It's all about making me happy. And I'll be happier with a bigger whiteboard. There, that's bigger. But what happened to our circle? It's not centered anymore. Well, so much for that idea. How could we possibly make it so that no matter what the length and width of our whiteboard is, the circle always shows up in the middle? I'll give you a hint. It's called parameterizing. We can parameterize the point. Now that I've used that big word, what does that mean in this context? How can I parameterize this point so that it always shows up in the middle? Mr. Vandiver, the spotlight is on you. How did you get those coordinates anyway? You're exactly right. Watch what happens if I mistype this. What if instead of putting actual numbers, I use my symbolic constants? Dr. England would be so proud of me. Width divided by 2 and height divided by 2. Is that what you meant? Let's try it and see. Run module. Okay. Ta-da! Self-adjusting. When you parameterize things like that, and oh my goodness, you're going to want to do that all through your graphics coding, which we will do for reals next week starting in the lab. You will want to parameterize out the wazoo. Everything should depend on symbolic constants. You may remember earlier I described symbolic constants as like the little knobs on an old-fashioned stereo system or something where you can adjust the volume and the bass and the treble and all the other stuff. Same thing goes for graphics programs. We should be able to just adjust our symbolic constants. And everything else in the code, parameterized on that, everything else on the code self-adjusts. Let's try it just to see if I'm putting money where my mouth is. I can't read that. I think it says 650. I'm going to go wild and crazy and make it 800 and make the height shorter. This is going to be a long, skinny rectangle. Instead of 425, I'll make it 375. That's not a lot different, but it's enough that I should see a difference in the graphics window. Run module. This video is going to be horrible. Look, it's a lot wider and it's a little shorter, but the circle is still right smack dab in the middle. Who has a question about this startling accomplishment that we just had? Click, it goes away. I need to catch up with some other stuff here. This, win equals graph win, my circle width height. That makes the whiteboard. P equals point. That made a point. We didn't display the point on the screen, even though it's a graphics object and we could. That would just show up as a black dot. We did make a circle. If you look at your circle objects in your handy dandy graphics reference, which are on, I spy, top of page 4. Top of page 4, to make a circle object, it wants the center point and it wants a radius. And I hate that example. Don't use their example as an example. Make a separate point first and then build your circle around that. And don't use numbers, use symbolic constants. But it wants to know the center point and the radius. Let's play with that a little bit. The center point, we've about worn that out. That's already parameterized. This radius of 10, that's pretty feeble. What if, just for poops and giggles, what if I want the radius, no, I don't want to pick a particular number. What if I want the circle, the entire circle, to be half as tall as the graphics window, no matter what? Did I say that too weirdly for you to formulate an answer? What if I wanted the circle that I draw on the screen to be half the height of the graphics window? How could I parameterize the radius of the circle to make that happen? Height divided by 2. Let's try it and see. I keep looking at my screen as if I'm going to see something, and it is solid black. The video better not be solid black. Oh, well, that's a pretty circle. It's a lot easier to see, but that is not half the height of the window. What happened? Can we reverse engineer what happened? We could just wave our hands and say, oh, I meant to do that, but I didn't. I wanted a circle that was half as tall as the graphics window. I'm sorry? Multiply? I think that might make it worse. If we multiply, it's going to get even bigger. Who can define for me, who is a stellar geometry student in high school, who can define for me what the radius of a circle is? Yes. From the center to the edge. If the center to the edge is half of the height, then the entire circle is going to be the entire height. Does everybody see that that's the case? Does that suggest what might be wrong that we might be able to fix if we can see our code again? What do we need to do instead of what we did? Divide by 4. It needs to be a quarter of the height. That way, when it draws the whole circle, the radius on top and the radius on bottom, those two together will be half the height. Or, in theory, I don't know if you remember the phrase incremental development from the lab work. Graphics has to be incremental development. You do one itsy bitsy baby step at a time, and you try that over and over and over again until it works, and then you go to the next thing. If you try to get an entire graphics program off the ground all in one fell swoop, then you're going to be grounded like a Delta flight trying to get out of Chicago right now. Ta-da! Now, it would be nice if we could claim perfection on that, except that isn't perfection. That circle is too skinny. I want to thicken up the circle. So let's look for a circle method that will thicken the circle. It'd be wild if they had one named thicken. The circle stuff is at the top of page 4, and we can either make a new circle, we can get the center, Well, we already know the center. We specified the center. We already know the radius. We don't need to get the radius. And we don't need to get P1 or P2 either one. So it doesn't look like there's any way we can make the circle any thicker unless, we remember this idea of object-oriented programming inheritance. What am I trying to suggest is another place we might look if we don't find what we want in the circle methods. Where else could we look? In the graphics objects methods, you're exactly right. Graphics objects are the parent class to all of the more specific geometric shapes. They have set fill, a color. No, that sounds fun, but that's not it. Set outline. No, that's close, but that also wants a color. That's no good either. How about set width? Set width sets the width of the outline of the object to the desired number of pixels. Aha. I think we have something to try. So, circle, be gone. And, who am I changing? Well, I'm not changing anything. I've got to add something. I've got a width and a height. I guess I need a thickness. Thickness. All the names of these symbolic constants are subject to change if they get confusing or it turns out they're not clear enough. But let's try a thickness of, it said in pixels. I don't know what it is already. I'm going to try 30. That sounds like a lot. And if that's too thick, then we'll come back and undo it. It says for a graphics object, you can set width, and the way you do it is to put the name of your object you want this to apply to. We want it to apply to our circle object. We want the circle to get thicker. C dot indent C dot set width. Man, I don't even remember. Memory of a fruit fly. Set width in pixels, and I was going to set it to thickness. The cursor has a mind of its own on this thing. I think the projector's a bad influence on it. Projector's just trying to ruin my life right now. C dot set width width. If I look back at this video and I don't remember the setup where I'm having to turn around and look behind me to see the screen at an angle, I'm going to watch this video on YouTube and think, good grief, what kind of drugs was I on? C dot set width thickness. See if that'll run. I'm still looking at my screen and there's nothing on it. Oh, man. If you can't see that, your eyes are worse than mine. Does everybody see what happened here? When we set width, it got a lot thicker. Now, I need to go back, or go forward. Here's what we've got so far. We made a brand new graph WAN. We got to do that before anything else because that's the whiteboard that we draw all our graphics pictures on. I made a center point all by itself before I made a circle because I like to do things incrementally, and you make the center point first and then you use that point to make a circle. And we chose height divided by 4 because we wanted the circle to be half as tall as the graphics window, and I set a width using thickness. Does anybody have any question or comment or anything about those so far? This I like to call the Mother May I step. After all this work and all this thickness and all these heights and widths and everything, you have to tell the object, the graphics object, to draw itself in the window. It won't do it unless you say so. So if you believe that, then if I can find the pound key, I think it's this one. What if I comment that out? What is this going to do now? Anybody want to conjecture, guess, hypothesize? There's my whiteboard. Where's my circle? How come my circle didn't show up? Because I made it a comment. I didn't say, Mother, may I? I didn't say, circle, you know everything you need to know about yourself. You need to know where you are on the screen. You know what your radius is. You know what your thickness of outline is. Now that you know all that, you got to draw yourself. What do you suppose, without me even doing any explaining, what do you suppose when get mouse does? Pay no attention to that comment. What do you suppose when.getMouse does? You can find out by subtracting it, taking it out of the file and seeing what it does. Run module. Okay. Did anybody see that? Run module. Try it again. I think I saw the circle for a microsecond. What happened? What happened with this get mouse commented out? What's it not doing that it was doing before? I know you can't see where I'm clicking up here, but when I'm running it, let me show you. Let me show you something. Run all back together as a unified program. Okay. I'm moving the mouse, but I am not clicking any buttons. You tell me when to click. You do a countdown, 3, 2, 1, and then I'll click. Not everybody all at once. Just one person. 3, 2, 1, click. You see what happened? It was waiting for me to click the mouse. When you say get mouse, it just sits there and waits for somebody to click the mouse, and then it goes on to whatever's next. In this case, there wasn't anything next. If I had drawn a square after that, then it would draw the circle first and wait for the mouse click, and then after get mouse, if I had draw a square or draw a rectangle or whatever, then it would do that after the mouse was clicked. The most mysterious one is when close. That's freeing up the main memory that we used for all of our graphics display. Windows close is picking up all the Lego blocks and taking them to the closet and all that stuff. It just cleans up the mess that we made in our graphics window. In other words, it releases that main memory for use by other applications. Okay? Now, we got some time left. Do you want to do, this will be a choice. Do you want to do some interesting geometry transformations first, or do you want to play with some colors first? Play with colors? Okay, you tell me. Look at your graphic stuff and tell me how to change. I think we already glanced over this and I kept going. How do we change the inside color of the circle? What page? Sorry? Page 2. Page 2, how do we set the inside color? Set Phil. Ah, yes, Phil. Went to high school with him. So we've already set width. Let's set fill. C dot set fill. What color do you like? Pink? And then it draws it on the screen. Let's see. Run module. Okay. That is it. That's an ugly pink. It looks kind of dirty, doesn't it? But we'll go with it. I guess that's the only pink we got. The outline is pretty harsh and severe to go with that pastel pink. How come we set the outline color? Does anybody see that anywhere? Set outline. Notice that all of these methods are not like print, which is like a standalone. It's called an external function. It's not associated with any object type. Things like set fill and set width and set outline, those only make sense when they are attached to an object. In this case, the only object we got to work with really is the circle. So it can't be just set outline all by itself. You've got to say what you're setting the outline on, and you do that with an object and then a dot. So that says, let's set the outline on circle C. What color do you want for the outline? Orange, really? Wild and crazy. Pink with an orange outline. Run Run module. Oops. Run module. Okay. Well, that's not a very appealing orange either, but we'll take what we can get today. Daddy's pink with an orange outline. Look how graphic we are. Okay, now let's get geometric. Let's get a little bit mathematical. And we'll say that's enough for one demo. There will be another demo down the road. But instead of being in the center, that's getting kind of boring, always in the middle. Let's make it down in this corner. In other words, I want this circle to be up against the left wall and also up against the floor. Holy moly. Here's some additional information that might have got swept under the rug because that's the middle no matter what. But if you look at the screen, this up here, that little square, if we were to draw graph paper on top of our whiteboard graphics window, that little square up there in the left corner has coordinates 0, 0. If we go all the way across the screen, that length is called, well, unfortunately, I call it length. That's the width, W-I-D-T-H. That's where my symbolic constant was used. If I go from there down to the bottom, this little square down here has coordinates width, comma, height. Has everybody got all that? Let me say that again. This point has coordinates 0, 0. This point has coordinates width, comma, 0. In other words, width across the window and 0 down from the top. This point has coordinates width, comma, height. Width across from the left, height down from the top. One more time. This point. Help me out, help me out. What are the coordinates of this point? How far over do we go to get to this point? 0. So the first coordinate is 0. How far down do we go? Height. Is everybody getting that coordinate system in mind? Did you do a little bit of coordinate geometry in high school or maybe even in college? Now, if that's the case, how far over from the wall do we need to go for the center of this circle? In other words, what does our x coordinate of the center of the circle need to be if we want it to be nestled down here in the corner? You know what? Let's do that incrementally too. We won't even do that. All I want is this ball to stop floating in the air and be down here on the floor. So how far across will the center of the circle be if I want it to still be in the middle but down here on the floor? What's the x coordinate, in other words? I'm sorry? Width divided by 2, the same as it always is. It's still going to be the same distance across as this circle is. How far down do I need to go if I want this ball to be resting on the floor? Height. So let's try that. The circle, P equals point width divided by 2, and we want just the entire height. That should put it on the floor. Oh no! Our pastel pink ball was made of lead. It went through the floor. What if we wanted to still be a full circle, but to be sitting on the floor instead of breaking through the floor? It looks like we went down a little too far. Yes, Mr. Vanderbilt. Height minus radius. There, think about that real hard. It's almost as if the ball is bouncing. We go all the way down height, and then we go back the other direction, the radius of the circle. Does everyone see the logic to that? To be successful in graphics, we're going to have to be logical as we can, and also get used to lots of trial and error. So instead of height, it needs to be height minus the radius. What's the radius? Height divided by 4, and I'm going to use parentheses after wazoo. Height divided by 4. Let's see if that puts the ball on the floor. Okay. The outline is thick enough that the outline bled over the border at the bottom, but still, mission accomplished. We'll say that's the ball resting on the floor. And it's still a lead ball, and it's so heavy that the outer edge of it got compressed against the floor. That's my story, and I'm sticking to it. There's a question? Let's, instead of continuing with geometry, well, that's actually going to be part of the next demo, probably. But instead of doing this, let's say we're satisfied with the ball in this position. Let's put some text up here that says, let's play ball. Look in your graphics manual and see how we can put words, also known as text, somewhere on our graphics window. Do you guys see anything? Page number? Page number 5. And what kind of object? Well, it's a text object. Of course it is. It wants a point and a string. And I've already said the string. I'll do the easy part first. T for text. Don't mess with me like that. I'm having a day already. Text, T equals capital T for text, and some point, I'll call it TP for text point. I'll worry about that later. And we want to say, let's play ball, exclamation point. So I got what I wanted to say. I just don't have, what is the point that it wants? I'll come up here, up a line, and make the point for it. I'll get it started while you're thinking about it. TP equals point. And I need to indent it because it's still inside the main program. TP equals point. What does the point object want? We've looked at one of those already. XY coordinate. Let me see. Anchor point constructs a text object that displays text string centered at anchor point. Text is displayed horizontally. That's wonderful. Okay, so what do we want the center point of our text string to be? How far across the screen? Yes.
The same as the, like with.
Same as the circle, so it'll be width divided by 2. Does everybody see that that's the case? We want it halfway across. Anything that has to go across has to do with the x-coordinate, the width, and all that. The up and down is the y-coordinate, the height, and all that kind of stuff. So we want to go halfway across. How far down the screen do we want to go? You can just yell out anything, and we'll try it and see what it looks like. 100. It must have been off the screen. Did anybody see it? Did anybody see it? Let's run it again. Maybe it just flashed and we didn't see it. Run module. There's the circle. And I click the mouse. But that ends everything. It goes away. How come we see the circle but we don't see the text? Mother may I. What's the mother may I step? We've got to tell the text object to draw itself. Oh my goodness, that can be a frustrating logic error to track down in your code if you're not careful. I didn't know, I didn't remember. I was reminded when I saw that on the screen. Which do I want to draw, TP or T? Is that such a logical nut to crack, really? T is the text object. Text, draw yourself on our one and only one window named when. Right? You could say yes, I don't know. I don't know until I run it if it's right. Run module. Okay. Let's play ball. That, that's a really good location. But I'm still a little bit uncomfortable with it. You might think that we would declare victory and move on, but I'm going to tweak this just a little bit just because those numbers showing up in code make me a little nervous. I'm going to say we're going to go a quarter of the way down. And go to the quarter of the way down, that'll be height divided by 4. Why? Why would I do that? Why would I do that? Because if the specifications change, if the width and height of the window change, I want everything that's drawn on that window to adjust itself automatically. You generally want to do that in graphics applications anyway. If you go from an iPad to an iPhone, you still want it to look proportionally correct. So you want everything that you can parameterize to be self-adjusting. Let's see what that does. This might be uglier, and if it is, we'll adjust. It's about the same place. That font is small. Is there a way to increase the font size? There's get text, set text, get anchor, set face, set size. Sizes from 5 to 36 points. I'm going to make it pretty darn big because I'm in a ball playing mood. Text size equals 35. That's not supposed to go there. Okay. And I've forgotten already. Now that I have my text object, what method do I use to change the size? It's going to be t dot something, isn't it? T dot set size. You'd think I could remember that. Camel cased. And my new size is text size. Run module. Okay. Ow! That's gorgeous, if I do say so myself. Now, we could keep fiddling with this, and you can keep fiddling with this. I will email you this source code, and you can think about changing the font, maybe change the color of the text, move the ball around on the screen, all those kind of fun things. We will be in graphics mode next week. The lab is about graphics. Project 3 is about graphics. So go back and review the stuff that we've looked at today. This would be a painful video to watch, but maybe you can watch it at double speed or something if you forget the finer points. But this will be posted on YouTube, assuming that it exists and it's not black and it has sound. But I'm going to call it a wrap, and I'll see you Friday. 3, 2, 1.